my name is Diego Kwan. Today I will be introducing the mechanically invasive ventilator developed by Project Inspiration at TU Delft. We will talk about the working principle, how to prepare it, and how to set up the controlling system. This device was inspired in the East Radcliffe ventilator, which was used throughout decades in Europe. So the principle works and has been proven. And it was updated with modern technology here at TU Delft. It has the addition that it has two subsystems, a mechanical subsystem and an electronic subsystem for monitoring. And this was designed with the intention of helping COVID-19 patients fight with the COVID-19 pandemic. First in the Netherlands, and then it expanded to other countries. Now we will talk about the essential components of the system, and we will do a walkthrough to each one of them. Here you can see the two cores of the two subsystems, namely the electronic board, which was tailor-made for this project, and the DC motor. It was chosen to be DC so it can be easily backed up in case of an electricity shortage. One of the main differences compared to the East Radcliffe is that now there's a motor controller, whereas before everything had to be done analogically. This simplifies the system and makes it more robust. The motor is connected to a main camshaft, which contains three cams, namely the inspiration, expiration, and the bellow cam that we will now look into. This is the main camshaft, which governs the behavior of the system. It contains three cams, namely the expiration cam, inspiration, and the one that controls the bellow. A lot of attention should be put during the assembly process of placing the cams in the right direction, because if they're put in the wrong direction, the behavior of the system will be wrong. And they look almost symmetric, so this is a part of a lot of attention. Then, as the larger cam pushes the arm, the bellow will pull in air and oxygen. Then, as the cycle keeps going, the weight will push the bellow downwards, and the air and oxygen will go to the inspiration valve, which is governed by a smaller cam. This will open the valve and push the air and oxygen into the patient. As the cycle keeps going, the expiration valve is opened by another cam, which pulls the air out and then out to the environment. The pressure is set up by the weights and also where they are located along the arm, and also through the PEEP valve. You can see here that there are sensors for oxygen flow and also pressure. Now we will look into the preparation before starting the machine. First, make sure that there is no extra weights. And remember that two weights are fixed. Then ensure that all of the connections inside are properly done. For example, the oxygen connection, all the valves going from the bellow to the inspiration and expiration valves, and all the sensors as well to prevent leakage. And lastly, make sure that the HEPA filter is connected properly, as well as the PEEP valve. So now we will see how the monitoring system works. We will first turn on the machine, then choose the previous settings, although we could choose the new settings. And then I will show how to adjust the pressure, breathing rate, and PEEP pressure, and then how to change the alarm settings. So for more information, please visit the official Project Inspiration website, namely projectinspiration.nl. And there you will find the direct link for the GitHub, where you can find all the assembly manuals and the technical specifications, the technical testing, as well as the drawings. And also follow the Guatemalan initiative in respiraguatemala.com to see the progress. Thank you.